Hello, my name is Davis Binger. Let's talk about partial derivatives and the chain rule. Today we will look at problem 4 of the 13.5 handout. We are asked to find the partial derivatives of f with respect to s and f with respect to t of the function f of xy, which is equal to e to the 2x minus y, given that x is equal to s times t and y is equal to s plus t. Now, the theory of chain rule and partial derivatives gives us the following two equations. The partial derivative of f with respect to s is the partial derivative of f with respect to x times the partial derivative of x with respect to y plus the partial derivative of f with respect to y times the partial derivative of y with respect to s. And a similar equation holds for the partial derivative of f with respect to t. Thus, to find the partial derivatives f with respect to s and t, we need only to calculate all of these partial derivatives and plug them in to these expressions. Now, uh, starting with f, we can calculate some partial derivatives. The partial derivative of f with respect to x. Well, we're differentiating e to the 2x minus y under the assumption that y is a constant. This differentiates to 2 e to the 2x minus y. The partial derivative of f with respect to y is negative e to the 2x minus y. The partial derivative of st, where we treat s as a variable and t as a constant, that is, we're differentiating this expression with respect to s, is just t. And if we differentiate it with respect to t and treat s as a constant, we get just s. Now if we differentiate y with respect to s, treating t as a constant, we get 1. And if we differentiate y with respect to t, treating s as a constant, we again get 1. Okay, we've made these calculations. We have calculated these partial derivatives, and now we just need to take these partial derivatives and plug them into the two expressions we had previously, one for the derivative of f with respect to s and one for the derivative of f with respect to t. So here's the partial derivative of f with respect to s. We plug in all of the appropriate expressions, and in this case, we want to make this derivative a function of s and t exclusively, so we go ahead and finish the problem off by plugging in our x as a function of s and t and y as a function of x and t. Once we do this, we have that the partial derivative of f with respect to s is 2t minus 1 e to the 2st minus s minus t. Alright, for the second partial derivative, we have our second expression, and we calculate this partial derivative similarly by plugging in the appropriate partial derivatives. Again, we will need to plug in for x and y with the appropriate functions of s and t. After doing so, we come up with a partial derivative 2s minus 1 e to the 2st negative s negative t. Alright, thank you for watching, and as always you can reach me by leaving a comment below or emailing me at binger@math.ohio-state.edu. Thank you, and have a good evening.